Hi, my name is Henry from UMass Amherst, and today I'll be presenting to you my research on automatically generating post-procedure documentation as part of the UMass Medical Safety Project. First, let's start off with some background information. Post-procedure documentation is a detailed record, usually written at the end of the medical procedure, that describes the process that was followed, any medical findings, treatments being ordered or conducted, and patient information. Now, preventable errors in medical procedures can cause the loss of lives. Previous studies have found that 350,000 to 500,000 patients undergo cardiac surgery a year, and of those, 28,000 patients will experience at least one adverse event. One third of deaths associated with coronary artery bypass graft surgeries are preventable. UMass Medical Safety Project uses carefully validated process models of critical medical procedures to proactively guide clinicians when performing those procedures in order to reduce preventable errors. Good documentation protects the patient for their future safety and quality of care, as well as medical providers, since it provides valuable information about the patient and is the basis for future learning and improvement opportunities. Traditional documentation is created after the fact, which may lead to incomplete and inaccurate documentation. It is also time consuming. In a 2019 study, 74% of physicians surveyed reported 10 plus hours of paperwork per week. Previous UMass student had studied the feasibility of automatically generating post-procedure documentation, and it was concluded to be a valuable asset for medical providers. The proposed documentation system will automatically generate an accurate record of a medical process, and it will allow users to add annotations, but all other data will remain unchanged to maintain data integrity. It will also reduce errors in post-procedure documentation while maintaining readability, and finally, it will allow users to generate customizable post-procedure documentation views for their specific needs. The approach for this research starts with the understanding of the process modeling language Little Jill and its editor. Next, we have to understand about the heparinization process, which is the case study being used for this research. Heparinization is a step for cardiac surgery, and the data for the heparinization being used for this research is synthesized but reflects real-world situation for heparinization. Next, we have to investigate about the post-procedure documentation that is currently done in the medical field, as well as the support and the design for the post-procedure documentation for Little Jill. We will identify key post-procedure documentation requirements, and based off the requirements, we will draft mock-ups that we will use to present to subject matter experts for feedback. Ultimately, based off the feedback, we will then design and implement extensions to the Little Jill environment to support post-procedure documentation. This is a sample process model for heparinization. Process model looks really similar to a binary tree, where you start from the very top, which we will call the root step, and it will decompose into many intersteps. Intersteps are non-actionable steps, but they provide a summary and abstraction for the steps below it. Ultimately, you will reach to a point where the step can no longer be further decomposed, and in which we will call these actionable steps. Additionally, what you will see on the very far right is an X with a red mark. Essentially, what this means is that when you start to perform heparinization and there's an error or there's an issue, you will start coming back up to find this red X and find the problem and try to handle the problem. And essentially, the red X will bring you to a step that further decomposes into more steps that helps resolve issues. This is an architectural model of the overall system. We first start with the process model that is being taken in by the smart checklist system. The smart checklist system will use the information from the process model to guide the clinicians via a user interface. The process execution monitor will take in data from the clinician as well as data from the medical devices attached to the patient and feed that information back to the smart checklist system. The smart checklist system will compile everything and generate a process history file in the form of an XML, and that file will be sent to the post-procedure documentation generator, which combined with the customization defined by the user will create the post-procedure documentation. The post-procedure documentation requirements are that it will use trace of process execution created by the little Jill environment to generate a post-procedure documentation as specified by the user customization. The documentation will capture, show, and format information that are team-specific, patient-specific, procedure-specific, and trace-specific. The documentation should support formatting concerns, customization concerns, as well as integrity and accuracy concerns. The post-procedure documentation header will contain a summary of what the documentation table will overall show, and is the first thing that you'll see in the documentation. Now, for the header, it will contain patient information, procedure information, in our case, heparinization, and the metrics for heparinization, such as ACT and heparin dose. It will also contain team information. Next, the main post-procedure documentation table is shown. Each row shows the steps in the process model that were followed and in what order they were followed in. Each column shows the category in which the information below it belongs to. For instance, here we have activity, time, teams, including primary team and support team, equipments being used, medical vitals, as well as procedure metrics, including ACT and heparin dose. Procedure metrics can be highlighted if it is outside of the acceptable range. ACT stands for activated clotting time, and for heparinization, it needs to be increased to minimize the chance of strokes happening in a cardiac surgery. In this case, ACT of 150 seconds is not accepted, thus highlighted in red. Later on, further down the process steps, where the ACT reads 180 seconds and is not highlighted in red, it is within acceptable range. Lastly, you will see on the right bottom are shaded rows, which indicate problems during the procedure, and the corresponding steps to resolve it is also shaded in the same shade. This is the customization menu, which the users are able to use to define the customization that they want for their post-procedure documentation table. First, we start with the customization profiles, which the users are able to save, delete, and change. Next, we have the customization of teams. The user are able to select whether to show the team or not, which color stands for which team, as well as give abbreviations for each team. Lastly, we also have general table layout customization, which allows the users to determine whether to show the column or not via the tick box on the right. Users are also able to arrange the columns using the up and down arrow corresponding to each row. The order of each column maps left to right on the post-procedure documentation table to up and down on the customization menu. Next, let's take a look at the mockup for our post-procedure documentation generator. And first start with the customization menu, which is by default, meaning no abbreviations for each team is chosen. Teams are shown by their full name. All teams are shown. There are non-actionable and actionable steps are both shown, and there's no customization for the columns. And this is what the table will look like. Next, let's take a look at a mockup for our post-procedure documentation that is customized. As you can see on the customization, what we've changed is teams are now abbreviated by the first letter for each team, and we only want to see actionable steps. We'll keep all the columns the same, meaning the columns all will be shown, and this is what the table will look like. Finally, what's next? We are continuing to work on the incorporating of user customization profiles. In the future, we will try to incorporate additional customizations such as the collapsing and expanding of table events. In the future, we'll also try to compute and display duration between actionable events, as subject matter experts did say those are key information that they look out for. Furthermore, we are currently studying ways to support surgical coaching, debriefing, and handoffs by incorporating video playback into the post-procedure documentation for when clinicians need to look at videos. And that's my presentation. Thank you for your time.